Hello everyone. In this session we'll discuss normal distribution. Hello friends. Now that we have already discussed exponential distribution and uniform distribution and continuous distribution, now is the time we'll discuss the third one, which is normal distribution. This is also known as Gaussian distribution. Now, again, this normal distribution is an approximation to the binomial distribution. So in case of binomial distribution where n tends to a very large value, but neither p nor q is very small, in that case, again binomial distribution will start giving error, and for the approximation we move to, or we limit it to, normal distribution, right? So under the condition where n tends to a very large value and neither p nor q is very small. So in that case, we approximate this binomial with the parameters n and p to a normal distribution with the parameter mu and sigma square, where this mu can be written as or given as np and sigma square can be given as npq. Density function sigma mu square is given as so we have this density function given as f of x is equal to 1 by under root of 2 pi sigma square e to the power of minus half into x minus mu by sigma ka whole square. And this curve is defined for the entire x-axis, which is minus infinity to infinity. Now this curve is the curve of normal distribution, which is known as normal curve, is a symmetric bell-shaped curve. So it is a symmetric bell-shaped curve, and the symmetricity is about the mean value about x is equal to mu. So it is symmetric about this mean value x equal to mu. And we know this for any symmetric curve, the mean, median and mode are all same. So I'll add it here. Being symmetric, its mean, median and mode are all same. So this curve will be given by, let's say it is a symmetric curve. This is x is equal to mu. This is x, and for a range, let's say this is x minus mu, this is x plus mu. Let's say this is x minus 2 mu, this is x plus 2 mu, and let's say this is the region x minus 3 mu, and let's say this is x plus 3 mu. We're just approximating it. So this function of x for this range of minus mu to mu plus mu, this will actually cover 68% of the overall distribution. And for this x minus mu to plus 2 mu, this will almost cover 95.5%. And then this x minus 3 mu to plus 3 mu covers almost 99, I'll say 99.7 or 78%, which is like almost 100%. So this will be a bell-shaped curve. It has to be symmetric, more proper than this, the one which we have sketched, and it is symmetric about the mean value. So moving minus mu from the mean and plus mu from the mean, this overall area, this area covers the 68% of the graph. And we also know that minus infinity to infinity, the integration f of x dx, where f of x is the density function, gives you 1. So what is this integration? It is the area under the curve, right? So this curve will have overall area to be 1. And now if this curve area is 1 and this is the mean value, that means on this side, on the left side of curve, it is covering 50%, and on the right side of the curve, it is also covering 50%, right? Obviously this is not the part, I'm just considering the left half, right? So this is the case that, so now this left half is having the same area as the right half, and we know that overall area is 1. That means this is going to be 50% of 1, which is 0.5. This is going to be 50% of 1, which is 0.5 on the left half of the right mean, and on the right half of the mean. Now, since the curve is symmetric, any distance from the mean covered on both the sides will have the same area. Like on this side, we are moving mu units. So this is x minus mu. The absolute distance is mu. Similarly, from x equal to mu, we are moving to x plus mu. Again, the same symmetric area, right? So we can see that the area coverage will be same. So if I am saying, let's take it till here. So if I'm saying this overall area from x minus mu to x plus mu is 68%, then this also means that this half will be half of 68%, which is 34%, and this is going to be half of it, which is 34%. Other than that, if we have to find up to x plus mu, then up to x equal to mu, we know this is going to be 50%. This whole area up to x equal to mu is 50%, and we know that x equal to mu to x plus mu is 34%. So 50% and 34% will be 84%. Likewise, we can calculate up to here, or likewise we can calculate up to here also. Why? Because this area from minus 2 mu to plus 2 mu is covering 95.5%. So we can reduce it to half, maybe it is 47 or 48 approximately percentage, and we'll see that half of this will be 48 and half of this will be 48. Now if we have this as 40, from we are starting from minus infinity, and we are like calculating all this area up to x equal to mu, and we need to find up to plus 2 mu, then we can add 48% of the right half plus the 50% of the left half. Similarly, if we have to find anything less than mu, so now we know up to x is equal to mu, we have 50% area, and we know that x minus mu and x plus mu has a range that it will cover 68%. So this is 34%. So if we are starting from minus infinity and ending up to x minus mu, then we can reduce 34% from the 50% we have. This entire area is 50% and this is 34%. So we can reduce and we can say this is going to be 60%, 16%, right? So or any absolute difference between from the mean will have the same area. That is also what we have to consider, right? So for x is normally distributed, let's say with n with mu and sigma square. So with the property of this variance and expected value, mean and variance, we'll see that if there is a transformation like z equal to x minus mu by sigma, then now what? We have this mean equal to mu and sigma is variance equal to sigma square. Now we know if we have for x, if we have the mean equal to mu, then ax plus b will have a mean of a times of mu plus b. Similarly, if x is having a variance of sigma square, then the transformation from x to ax plus b will give an area sigma of or variance of a square times of sigma square, right? So let's say this is the new variable x star, which is given as z. So this is the transformation, and if you compare this transformation with this expression ax plus b, you can see that this is nothing but 1 by sigma into x minus mu by sigma, right? Ax plus b. So this is ax plus b, which means a is 1 by sigma and b is minus mu by sigma. So in that case, with the original mean to be mu, the mean is going to be 1 by sigma into a times, so a is 1 by sigma into mu plus b, so b is minus mu by sigma. So this is going to be 0. And similarly, the transformation ax plus b says the variance is going to be a square plus sigma square. So what is a here? A is 1 by sigma square, so 1 by sigma. So this is 1 by sigma square into sigma square, which is equal to 1, which means this is the new mean and this is the new variance, right? So this z, which is also known as standard normal variate, so standard normal variate, which is z, the normal distribution now becomes the mean with the mean 1 and sigma square as 1, 0 and 1. The mean becomes 0 and the variance become 1. So if we, I'm just roughly drawing, let's say this is the curve, then this is the mean value is going to be about z equal to 0. This curve is going to be about z equal to 0 because that is the new mean. This is z, this is f of z, right? So this is the standard normal variate and we'll be using it in many cases. So we have to make sure that we know what is this, and as per that what is the variance and mean, right? So this is very important. Now to find the distribution function f of x is equal to a, this is nothing but the probability of x for less than equal to a, and this can be again transformed. So for x less than a, we can transform it to probability of, let's say, x minus mu by sigma less than equal to, instead of a it will become a minus mu by sigma, right? And this is given as function phi. You can either say a minus mu by sigma, where this phi of x is cumulative distribution function of standard normal random variable. Standard normal random variable means the mean is 0 and the variance is 1, right? Like we know this z is equal to x minus mu by sigma is the standard normal variable. So instead of x, we are switching it to x minus mu by sigma. Apart from this, a small concern we have is this is sum of independent normal variable. So let's say if x1, x2 and maybe up to xn are all independent normal random variable with mean given as, let's say, mu1, mu2 up to mu n, and with, let's say, variance given as sigma 1 square, sigma 2 square up to sigma n square, then the linear combination of these, and this linear combination given as y equal to, let's say, c1 times of x1 plus c2 times of x2 up to cn times of xn, where this ci are scalar coefficient or constant coefficient. In this case, this y will also be a normal random variable. It will also be a normal random variable, and the mean mu y will be given as c1 mu1 plus c2 mu2 and so on up to cn mu n. Similarly, this sigma y square, that is the variance, will be given as c1 square mu sigma 1 square plus c2 square sigma 2 square and so on up to cn square sigma n square, right? So we'll see the questions now and we'll understand more about this topic. So this will be all about the understanding this normal distribution.